Okay, showing me capturing the whole window, whole display now.
It is. The reason I bought it was because I could use the GPU for analysis.
Is that better?
Yeah, okay. I'm not really using it. Because I don't know how to Google.
Yep. All right. Now we're really back. Okay. Const variables. So when we declare our variables, we can declare them as const. And const basically means read only. It says, once you've created this thing, you can never change it again. And why do we want that? Well, it allows us to avoid accidentally writing to something that we shouldn't be writing to. Helps us. The main use of it is it helps us prevent mistakes in our programs. Also, in some cases, in some limited cases, it allows the compiler to optimize things a bit more because it knows that this thing can never change, so it can avoid generating any code that would be required for writing to this type. So const is great. Use const everywhere. Const is brilliant. Const is one of the best things about C++. So one of the things I try and do is to basically declare all my variables as const. And only if I later find out that I need to change it do I make it usable. But as much as you can, declare your variables const. It'll save you problems. Save you from problems later. And it's quite an interesting one that constness is actually a property of the type, not of the instance itself. Right? So in this example, here I'm declaring constant I. So now I, we've initialized it to 4, and we can never change the value of I after this. But the type of I is actually constant, not int. So if you want to sort of think about it in a way, every mutable variable can be changed, implicitly converted, if you like, to a const version. So if I had a function that took a reference to a constant, I'd be able to pass this thing. But I'd also be able to pass just a plain int, because a reference to a plain int can be converted to a reference to a constant. But the other way around is not true. So if I had a function that took a reference to a plain int, I would not be able to pass this guy I. Because a function that took a reference to an int may well change that int. And if I tried to pass this, it would say, no, you can't do that. So constness, technically, is part of the type.
So if you put ampersand I in your argument, you couldn't pass that. That's correct.
That is absolutely correct, yeah. I need those in a minute.
Can't refer to an R value, did you?
Yeah, a reference value.
A reference value can refer to something that exists.
Yeah, so you
That's something that has a lifetime. 4 is just, there's no lifetime of 4, right? 4 doesn't exist.
Yeah, your argument could be I. That implies.
Yeah, because that's what we call an L value. Or
It
can, so just the ampersand means I refer to an L value. It means I refer to something that lives past a line. So 4 is what we call a PR value, a pure R value. It exists on the right hand side of something.
So we read types from right to left. So this means a reference to a constant. And if this was a function argument, and I try to call this with my constant I, can't spell very well, then I can call func I, and that's fine. Because this is expecting a reference to a constant, this is a constant, that's absolutely fine. But if I got rid of this const, now it's expecting a reference to a mutable int. And so now if I try to do this, and I try to pass a const int to something that expected a reference to a mutable int, now that's not going to work.
Because the types are different.
Because the types are different, exactly. However, if I put the const back again, like that, then this call would be okay. But if I now declare another int, let's call it j, now this is a mutable int. I can change the value of j, but I can still call this function on j. Because this is a mutable int, and this is expecting a reference to a const int. But that's fine, because if you like, a const is a sort of more restricted type. We're adding a qualifier. This is more restrictive. So this is saying, I promise not to change the value of R, the value of your argument, the value of my argument. And that's fine. If we can pass, this is still readable, right? So we can read and write to this. So we're passing it to something that only reads from it, that's fine. We're saying you can't write to this, so if we were trying to pass it to a function that wanted to write to it, the compiler would stop us. So you can't do that. Does that make sense? No.
I think this might be why I'm so confused, because when I'm looking at those 4 lines, I see an I and I see a J, and I don't see the relationship between the two apart from the int. Are you saying that the J?
Okay, so what's on this line, I'm declaring a variable I of type constant.
Yeah.
I'm initializing it to 4. Here, I'm calling the function func, which I've declared up here,
yeah.
and I'm passing the variable I
yeah.
to this function, and that's okay, that's fine. Here, I'm declaring another new int called j,
yeah.
and I'm initializing it to 0, and here I'm passing that variable to this function again.
Oh, to that same function.
Yeah. So I'm calling the function named func, calling it twice. Right, so just imagine this was in a header.
Oh, I thought func was a keyword.
Oh no, sorry. Function's just the name of, I couldn't think of a good name, so I just called it func.
Okay.
So this one, the top one would be in the header, and the second one would be in the implementation. 35 minutes, plenty of time. Well, speaking of functions, let's talk about functions.
Can I just ask a quick
Oh yeah, sure.
So is the advantage of const that it knows that it knows what the value is at compile time? Is that what the advantage of having?
Not always, no, because you imagine you can declare variables. I'm just going to wipe this off the board a second. Do you want to take a picture of it?
I suspect I know what you're possibly getting at, which is that if you declare a parameter by value, so I take, say, const string, really you should probably just take a const string ref anyway, but technically speaking, the compiler can, yes, see through that as an optimization and say, well, it's const, so we don't need to bother copying it. That is an internal optimization, but that shouldn't be why you do it. You should be doing it because you're saying, this is read-only, this is not modifiable.
Okay, cool.
Is that clear?
Yeah.
Okay, well.
With my explanation, I believe you did a great job.
Right. A C++ program is composed of functions. That's the hammer we have. Everything is made up of functions. We start off our execution in a special function named main. Every program has a function called main. There's only one of them. It always returns an int. It can either take no arguments or it can take a special pair of arguments that what you pass it on the command line, if you call it on the command line in Linux or Unix. And generally speaking, we can pass any number of arguments we like to our functions. I'm right in the way, sorry. And these arguments, they're the data for the function to operate on, right? And there is an upper limit, but it's in the thousands, more than you would ever want to write. You can have as many arguments to a function as you want, practically speaking. And functions can optionally return a value as well. Functions either return one value or no values. Right? You can't have multiple return values in C++.
Everything in C++ is made of functions. Everything. Int is also made of function. Made of a function. Isn't it a class? Because like when you say that, it just
the code that runs, right, is all composed of. Effectively, what happens is it all gets compiled to instructions that gets executed on your CPU. So we have it's all ones and zeros.
Yeah.
The CPU says
so
modify these ones and zeros in such a way that something useful happens.
Okay.
Yeah. So perhaps I was oversimplifying by saying it's functions. It makes it sound like a functional language. We have data as well, of course, but the functions are what modifies that data. So there are two kinds of functions in C++. We have member functions and we have non-member functions, also called free functions. So if you're used to something like Java, Java doesn't have free functions, it only has member functions. It calls them methods. So in Java, everything has to belong to a class, even main.
So that was what I was asking about, whether it's like Python, where everything is an object class, or whether it's you have actual functions where just functions.
We have functions that are just functions, they're called free functions. We also have member functions, but as we'll see, these are sort of a lot like normal functions, except you get this extra special hidden parameter, the object that you're operating on. Python, by the way, has free functions as well.
Sure.
Pretty sure. So yes, member functions are functions which belong to a class or a struct, or a union technically if you really want to use it. And you can sort of think of member functions as having this. Member functions always operate on an object, and you can think of it, if it helps, as the object being passed as an extra parameter. So again, in Python, you'd write that explicitly. Usually call it self. In C++, it's kind of done for you. I actually say you can think of it working that way. In fact, that is exactly how it works. That is literally what happens, is that you write your member function, the compiler will translate it into a free function that has this extra parameter, which is this, which is the object you're operating on. We'll talk about member functions a bit more in a minute. The important thing is, before we can use a function, we have to declare it. Literally has to happen above, in your source code, above where you call the function. You first have to have a declaration of the function. Once a declaration, it means the name of the function, its return type, and its argument types. How many arguments it takes, the types of these arguments. So you're all familiar with this already, but this is what a revision session is for. So the form that we write it, we put the function name, and then in brackets, put its arguments. That's type name. Technically, the argument name is optional. You don't have to include it. The argument type is not optional. And then this is repeated, so you can have 0 or more, however many of those you like. And then at the front, we put the return type. If the function doesn't return a value, then the return type is void. As I've said there. So this should all be pretty familiar if you've been coming to these classes for a little while. Hopefully. We've written quite a lot of functions now. And function declarations are typically placed in header files. So this thing about having separate declarations and definitions comes from C, and it's a bit unfortunate. that we still have to live with header files, this 1970s way of composing programs, we still have to live with it in 2018, which kind of sucks, but we cope. But we would place the definitions of our functions in header files. This is just a source file that has declarations of types and functions and things. And then in our implementation files, we include these headers, and that literally copies and pastes the text of the header into the top of our source file. So it takes all our declarations that are written in the header, and it was as if you just copied and pasted them in your editor into the top where you wrote the include. So function declaration, return type, function name, type name, type name, type name, close your bracket, and then the semicolon. Yeah.
I was reading about member variables instead of function members.
We'll get to member variables and member functions in a bit. So this is a free function. So this is outside of a class. We'll talk about class members in a few minutes.
So, just to, because you said, so a free function is anything that does not belong to a class, basically.
It's a function that is outside of a
function
class.
that doesn't belong to a class.
Yes. Yes. Okay. Sounded like you had a follow-up.
It's just, because you said Python has free functions, I looked it up, and everything in Python is an object. So it's like, I was just making sure that the free function is actually what I thought it was.
A function in C++ is not an object, it's a function.
Sorry?
Function's just a function, it's not an object. You can take a pointer to the function.
So a function is just a list of instructions
in
C++. And you give it some data to operate on, the arguments, and it can return one piece of data, or nothing. And that's all it is, really. So,
I mean, think of this, you can copy objects, right? I can copy a string, I can move a string around, I can copy it around. I can't move a function or copy a function. It's just there where it is in the program. I can make a pointer to it, and I can call it through the pointer, but I can't ever copy a function. I can't copy a function, it's a function.
Unless, well, what if it's a method? Then it's still a function that belongs to a class.
So that function still lives fixed in place. It just operates on the instance. So the compiler is transparently having this invisible variable that it's passing around for you, which is this really, right?
So if it's a method, it can still be a free function.
No, it's not a method. That's we call them member functions in C++. You'll think methods in Java, for example, right? They operate on an instance of their type. So there's an invisible parameter at the start. Like imagine I could make a function, right, that just takes some struct type like tref and operates on it, call it self. The compiler just does this for you with member functions by giving you this implicitly at the start.
we're going to talk about member functions in a minute. We're going to talk a bit more about structs and defining our own types and things. But for now, let's think about free functions. These are just like functions are in an imperative language like C. In fact, they're identical to C functions in their syntax and everything. They work. So it's just a function. It's just a list of just a list of instructions for the compiler to execute. And we give it a name, arguments, and we have to declare them before we can use them. One thing I didn't mention on the slides is that in C++ we're allowed to overload functions. That is, we're allowed to have multiple functions with the same name, but different arguments, argument types, different number of arguments. And that's something that's not allowed in C, but we can do it in C++. So that was function declarations. Now we're talking about function definitions. We write a function definition. We write the signature, that is the declaration. The signature of a function being its return type, its name, and its argument types. We write the signature, followed by the body of the function in curly braces. So again, if you've been coming to these for a while, this should all be pretty familiar, right? You should know how to write functions, hopefully. Now this is important because we can declare a function as many times as we like, but we can only ever define it once. It's something called the one definition rule. It's a very, very important rule in C++. We can only have one definition of a function. So typically, we place the definition of a function in an implementation file. We put the declaration in a header, the definition in an implementation file, that is, a CPP file. And then if you remember all those diagrams from a couple of months ago now, how we pass the implementation files individually to the compiler, which then constructs these object files and then passes them to the linker. And the linker is the bit that resolves all your function calls. And if you try and define the same function in two different implementation files, what will typically happen is that it will appear to work until you get to the linker, and the linker will say, hang on, I've got a duplicate definition of this function. What's going on? You've done something wrong. And if you're really unlucky, the linker won't complain. You'll just get mad things happening at runtime. And this is also an interesting one. So technically, every definition is also a redeclaration. So remember I said you can declare a function as many times as you like. When you write the definition, that is technically a redeclaration. So why do I mention this? It's because if you have a function that you're just using internally in your implementation file, so it's not a public thing, not something you're going to reuse, it's just something you've done for your own convenience in an implementation file. If you place its definition above where you use it, that is a declaration. So you don't have to write a declaration and definition immediately one after the other. The definition by itself suffices, as long as it comes above where you actually use it. Does that make sense? I've got getting some nods. Yeah, excellent. Cool. All right. That was functions, by the way. That was like a whistle-stop tour. Had I been here at the start, I would have said I'm absolutely racing through because I had basically an hour and a half to cover 15 weeks of material. So this is an absolute whistle-stop tour of what we've covered, and there's lots has been left out, obviously. But if you do have any questions, then just yell at me, as you have been doing. It's fine. So we can declare a new type, our own data type, using the struct or class keywords. Structs and classes are basically exactly the same thing. They only differ in some of the defaults. They're different two ways, just the defaults that are used for member access and inheritance level. If those words don't mean anything to you, and they won't, well, they might not yet because we haven't covered them yet in this course, struct is what you want for now. In the next block, probably, we'll talk about a bit more about classes. Well, we'll talk about what the differences are, and we'll start using the class keyword a bit more. But for now, we'll just use struct. But when I say struct and class, I use them pretty much interchangeably, right? So, even use them interchangeably in these slides, I think, depending on which day I wrote it. So struct is composed of member variables, which in other languages are called fields, and member functions, which are called methods in some languages, that operate on the member variables. That make sense? Yeah? So within a struct, we declare our member variables in exactly the same way as we would declare them in just as local variables within a function, with one exception that I'll cover in a second, but this is what it would look like. So we declare our struct, so I've called it student, declared a member variable called name, which is of type standard string, and member variable called ID number of type int, and I've given this one an initializer of 0. That's optional, but just showed you just to demonstrate it. The exception is that we can't use auto here. You cannot use auto. You have to actually write the type. But other than that, it's exactly the same syntax as we have for declaring local variables inside a function. As member variables, I told you this was brief, right?
Do you not have to say private before the struct?
If you wanted them to be private, then you could put the keyword private, followed by a colon in there.
Would you have to choose either private or public, or can you just not? Because if it's going in the header file, shouldn't you have to stipulate whether it's public or private?
This is the difference between classes and structs. So in structs, everything is public by default. In classes, everything is private by default. That's basically the only difference. There's one other minor difference, but that's basically the only difference. So we haven't really talked about public, private. There's another level called protected as well. We haven't covered that yet. So for structs, everything is private. So had I written class there and then put the word public, followed by a colon, it would be identical, exactly the same. So member functions. Just in the same way we declare member variables using the same syntax, we declare our member functions using the same syntax as we do for free functions. Except that it goes inside the struct. We write the declaration of the function. That's the declaration of the member function. But just in the same way, we also have to write a definition, which we typically do in our CPP files, in our implementation files. When we write the definition, we have to tell it which class that function belongs to, which struct that function belongs to. So we do that by writing this. So imagine we've got a struct called foo, it's got a member function called bar. When we write the definition, we write foo : bar, which means function bar belonging to class foo. So this is when we write the definition. The declaration we've already written inside the body of the class or the struct. So the compiler already knows it belongs in there. But when we write the definition, you can imagine you might have lots of different types that all have a member function called bar. So if we just wrote bar, what we'd actually be writing would be a free function. The compiler wouldn't know that we meant the function bar that belongs to foo.
So did the two colons
Yes,
scope resolution,
that is correct.
and it can be for either class or type. In the previous slide, you had int or std. What was
Yeah, that's a namespace. So scope resolution, what it means is look inside this thing for something named bar. So look inside foo for something named bar. And the thing on the left of a double colon can either be a namespace, like std, or it can be a class. Not at the same time, right? So I could say like namespace : foo : bar. Yeah. But foo can only ever be either a class or a namespace. It can't be both.
So just one question regarding the declaration. The declaration is in the header file.
Yes.
So you'd say, why? So I have this sentence where I write like void and then function const. So why would I do that instead of what? Actually, what is that doing? Void is the return type of the function, but the const is the.
Let me go on to the next slide, and all will be revealed. Oops, or it would be revealed if I hadn't pressed the wrong button. Oh, next slide but one. Sorry, got ahead of myself. So a member function always operates on an instance of the class. Right? And within the body of a member function, we've got this special keyword this, which gives you access to the instance that you are operating on. For arcane reasons, this is actually a pointer. Shouldn't be, it should be reference. It's not. Silly, but yeah, we're lumbered with 40-year-old silly decisions. So this is a pointer to the instance we're operating on, but it's still there. This is what I was saying earlier. You can imagine it, if you like, as the compiler automatically passes an extra argument called this. So we've got an eraser somewhere. Oh, right. So this may or may not be a helpful way to think about it. If it's not, then just ignore what I'm saying. So just we had before, we've got struct foo, and now we've got this member function bar. You can imagine that this was really doing something like this. So you can sort of imagine that this is writing a free function that passes the instance as a pointer. That's how things work under the covers. Some people find that an easier way to sort of understand what's happening. If that kind of just confuses you, then just ignore it. Just feel free to ignore this bit. This is actually really what's happening under the covers. Right? It's translating this to some like weird mangled type name, function name. But this is really what's going on. So within the body of this function, we can write, this to, let's put a member variable in there. This j equals I. We wanted to. So this is a pointer. We use the arrow to look at the thing that this is pointing to, and we set it equal to I. Again, I don't want to sort of labour this too much. I just included it because sometimes people find member functions a bit easier to reason about with that explanation. The other thing to mention is that within the body of a member function, we don't have to write this followed by an arrow. We can, but if we just write j, the sort of this arrow is implicit. So we could just write j equals I. We don't need this followed by an arrow.
When do you have to write this?
Very rare cases that involve templated base classes, and I wouldn't worry about it. There is only, okay, so the only time other than that you have to worry about it is if you've done something very silly and you've named this argument j. So now you've got a function argument called j and a member variable called j. So if you just refer to j in the body, it's going to be in the argument, the function argument. So what you then have to write be this j equals j. Right? This is very silly, this is very confusing, don't do it. To stop you doing it, often what people will do is my preferred style is to put an underscore after the names of my member variables. So in the body, I always know which ones are my members. Other people, another very, very common pattern that people do is they'll put m underscore before the names of their member variables. That's also a very common one. I prefer trailing underscore.
If you want to return this, you put in the int foo garbage.
If you want to return,
If you want to return this from your function,
yeah,
it would be int foo bar.
int foo.
Because int is the
Well,
is
what's the type of this?
think it's an int. It's J.
No. What's the type of this? What's the type of the object that you're operating on? It's in fact written in this sort of pretend foo start, foo pointer. Yeah. So if you wanted to return this for some reason, you'd write your return type is foo start, and in that case, you could return this if you really wanted to. It would be a strange thing to do, but I'm just going to change it back to how it was.
We did it in one of the examples. It returned the star this.
Star this. Okay. So star this. This is a pointer. So when we write star this, it means dereference the pointer. So it gives you a reference to the object that you're operating on, a reference to your instance. And yes, so from copy assignment operators, you return a reference to yourself.
So that would be foo ampersand then.
Exactly. Yes.
Right,
Perfect.
just quickly, because I've just finished with the things and missed something. What's void return this? What?
What?
I've obviously missed some context, but that originally said.
I changed.
Okay.
Halfway through changing it back to what it was before. That's okay.
Is this a pseudo piece of code?
Yes, exactly.
Okay. This is not valid C++. You can't use this as the name of the
No,
function.
this is pretend. Right?
Yeah.
This is kind of imagining what happens under the covers. Not imagining. This is what happens under the covers.
Yeah.
But again, as I say, just to reiterate one more time, if you felt like you understood it before and I've confused you, then just ignore it. You don't have to know this. I only mention it because some people find it. What have I done? Have I done something wrong?
No, that's only if it's a fast call. This call uses one.
All right, they're discussing calling
assembler,
conventions on
ignore
Windows.
us.
I think we're safe to move on. So, member functions may be declared const. This is what you're asking about. So, if we want to, we could put the word const after our declaration. And what this means is that the member function can operate on a const instance of foo. So if we, somewhere way over here, in another file somewhere, we wrote const foo f, curly braces, and then we did f.bar, that would be fine. Because we've declared this member function as const, which means I'm allowed to operate on a const instance of this. Without, I could do const foo, I just wouldn't be able to call the bar member. So if I got rid of that const again, if it just looked like that, then if I tried to do this, it would say, no, you can't, because bar cannot be called on const instances. It can only be called on mutable foo. So it doesn't mean that you can't create one of these, it means you can't call that particular member function.
Does that mean it only works on the const?
No, it doesn't. So now, this time I have a const member function. I get rid of this. So now f is just a normal, regular, mutable foo. I can still call the bar member function because it's in the same way. Const is a promise that I will not change any of the member variables inside there. It's saying I will only read my member variables, and that's fine. You can read things from a mutable type. You can't write them in an immutable.
Well, that's a key point. That when your member function is const, everything you do inside your member function, like all of your fields, they have all become const as well automatically. The compiler makes them all const. So if you want to have, you can have an overload. I could have a void bar int I that's not const. So I can have both. I have one bar that's const, which works on the const instance, and I have bar again, it's not const, and that one can mutate stuff.
So
you have,
Not a particularly good idea, is it?
depends what you're doing.
yeah, no, it's quite a relatively common thing to do. particularly for the square brackets operator. But so, as Ollie just said, within a const member function, the compiler will prevent you from making any changes to your member variables.
Unless they're declared mutable.
So it's as if all your member variables had been declared const. And again, if you want to sort of know what's happening behind the scenes, then it's as if,
It's not const foo star.
yeah, let's say. Within the body, so if you want to know what's happening with this sort of translation, within the body of a const member function, this has type pointer to const foo. So if I tried to do this, the compiler would say, no, 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 you can't do it. Because J, you can't change the value of J within a const member function. That's a no-no, that's not allowed. Think about it a little more deeply. When we dereference this, we access this. This is a pointer to a const foo, so when we dereference it, we get a reference to a const foo, and we can't change the destination type because it's const. So that's what the trading const means. But again, this is sort of pseudocode. You cannot write this. This is just a bit of detail of what's happening behind the scenes. Let's get rid of it before somebody looks at it and goes, that's not real C++.
So within the header file,
Yeah.
I might see member functions that are tied to a class instance, and I might see three functions,
Exactly that, yeah.
and those are just kind of like, those are not tied to a particular class.
Absolutely, 100%, yes. So, within a header file, you might see something like this. So this tells you there's a struct foo that has a const member function called bar, and a member variable called j, type int. And then you might see a free function. So it's the declaration of a function that's written outside of a struct body. And this is just a free function that operates. In this case, takes a string parameter and returns an int. Maybe it returns the length of the string. Doesn't really matter what it does.
Is there an example of a free function that you've seen often, like that's trying to accomplish something?
Oh, goodness me, thousands, millions of them. It's the first free function that comes to mind.
It does a specific thing.
It does a specific thing.
And it returns 0.
No, say in the standard library. Printf would be a C one, yeah. So the whole CO doesn't have member functions. It only has free functions. So yeah, anything that's in the C standard library. There are lots and lots in the C++ standard library. My mind is only going to really quite complicated ones like standard move and standard transform now. C out is an object actually. Yes.
Stream.
There's a function, for example, there's a free function called make pair. And you can pass it, it's a function template actually, so you can pass it any two things you like, and it will return you a type called a standard pair, which is just a struct with two members.
Various math functions.
Sorry?
Math.
Yeah, all the math functions. Square root.
Oh, okay.
Square root doesn't belong to an object. Again, that's a C function, but yeah, that'd be a good example. So you have you have a free function square root sqrt, takes a double as an argument and returns you another double. That doesn't have to belong to an object. It doesn't have any state. It's not modifying anything. Doesn't have any instance to operate on. You just give it a double as an argument, and it gives you a double back.
It's kind of like a clear demarcation between object-oriented programming and functional programming, I guess.
Well, I wouldn't call it functional programming. You'd probably call it imperative programming. But I guess, yes, there's a reasonably clear demarcation. But in C++, we can do both. Or either. It's up to you. Right. I'm nearly out of time. But we don't have much left. Let's briefly talk about operator overloading. C++, we have this wide range of operators, plus equals, minus, divide, percentage, or modulo, loads of them, or 35 or something, it's tons of them. And the language allows us to define what these symbols mean for our own types. Effectively, when you write, for example, I plus j for two instances of your own type, you're allowed to decide what happens when you write that in your source code. And this is a process called operator overloading. And to overload operators, we write a function whose name is operator something. I've used the @ symbol. The @ symbol isn't a valid one in C++, but I've used it as a placeholder. So it could be operator plus equals, operator slash, operator, whatever you like. Any of the valid ones. And we write a function whose name is that. Almost every single operator in C++ can be overloaded. There are 3 exceptions. And they're trying to get rid of one of those exceptions, as if it wasn't confusing enough. We can write almost all of the operator overloads either as member functions taking 2 arguments, or taking 1 or 2 arguments. Sorry, non-member function taking 1 or 2 arguments, or as a member function taking 0 or 1 arguments.
Yeah, but why? Why would you do this? Why would you use, what's the use case for it?
All right, so imagine you've written your own mathematical vector type. So a vector is like a 2-dimensional value. In mathematics, it's really useful. You can add 2 vectors, right? So you might want to provide an overload of plus for your vector, your vec2 type. Because that's what you'd write in maths, and especially if you compose a lot of these operations, the composition operation looks exactly the same as it looks for ints, and it's a lot clearer than going add brackets AB and then take that result and multiply it by this matrix. And a lot of people don't like operator overloading, actually. They claim it makes your code more unclear, and it's not obvious what's going on. But
To do like another comparison, like let's say you were creating a game where you had 2 characters that they had like a speed, hit points, magic points, and that when you combine them, they form like a new character or something. So basically, since those 2 objects are the same type, they're both characters, they have the same attributes and everything. If you just put plus between them, it doesn't know what to do with those 2. So basically, overloading is defining what happens when you add those 2 things. Is that right?
yeah, if you like. So
Or say if you make a class that represents a complex number.
yes, perfect.
Imaginary as part and the real part. So your normal C++ plus operator would not work on 2 objects of such a class. If you do overloading, so you can define the logic.
Yeah.
Wherein you independently add the real part and you independently add the imaginary part.
How long do you need? Sorry. Okay, 5 minutes. Okay. Operator overloading allows us to do all manner of silly things. We could define plus to subtract 2 numbers if we wanted to. It would be silly, but we could do it. So the golden rule really is don't be silly. If you're going to write an overload for operator plus, make it do something that is like addition, right? Otherwise, you're just going to surprise people. So do as the ints do is basically a good way of thinking about it. So if your type doesn't have a meaningful plus operation or multiplication or whatever, don't overload that operator. Make somebody write a named function that says what it does.
There's no inference in C++, I think is what you're saying.
Inference.
It's not it's not going to infer because I have two characters that plus means concatenate, for example.
For strings.
For strings, it's not going to make assumptions, and so because it's not C++, it's not going to make assumptions. Operator overloading will help you tell the computer how to treat it.
Exactly. So for strings, a string is not a built-in type in the language. It's provided in the standard library, and the standard library actually does provide an operator overload for plus that takes two strings, that concatenates those two strings, glues them together.
It's not part of the language. They literally wrote an operator plus forested string, just like you would do one yourself.
So I'm rapidly running out of time. Race through. Constructors, we only talked about these a couple of weeks ago, so we shall race through them. Constructor is a special sort of member function that is called by the compiler when you create a new instance of a particular type, of a class or struct. So we write constructors the same way we write any other kind of member functions, except that they have no return type. So we were to write a constructor for our class foo. We just write it as foo, and then maybe it takes an int. So this would be a constructor for class foo. Has the same name as the class, as its containing class, doesn't have a return type. In the definite, so again, just like any other member functions, we can write the declaration and the definition separately. In the definition of the constructor, we can provide this thing as the member initializer list. So here I've got a little struct example. It's actually pretty much identical to foo on the board there. I've declared a constructor that takes two arguments. I've also got these two member variables, I underscore and f underscore. As I said, that's my personal preference for how to write member variables. And now I've written the definition of the constructor. So you see, it's written like a function, except it has no return type. And then I've got this thing called the member initializer list. So after the signature, we write the colon, and then we list all of our member variables, and we write the value that we're initializing them with. So in this case, we're taking our member variable I underscore, and we're initializing it with this function argument I here. And we're doing the same for f. It's still a function definition, so we still have to provide a body. In this case, we've got nothing left to do. We've done all the useful work in the initializer list, so the body of our function is just empty.
In initializer lists, do you have to use curly brackets to...
You can use round brackets, or curly braces. You can't do the equals form. That was constructors. In about 30 seconds. So we're at destructors. A destructor is just the opposite of a constructor. It's called by the compiler automatically when an instance of your class gets destroyed. So usually when you leave the scope in which you declared it. Right? This is, as I've banged on about many times, the best thing about C++, this deterministic destruction. The job of a destructor is to basically undo whatever the constructor did. That usually means releasing any resources that you got a hold of in the constructor. So if your constructor takes a lock on something, your destructor should release it. If your constructor allocates memory, your destructor should free that memory. Just the opposite of what the constructor does. You always have a destructor. Every class has a destructor. If you don't write one yourself, the compiler will give you one that does nothing, but every class has a destructor. You can't not have one. One thing probably to note that I didn't write in here, but you don't have to worry about destroying your own member variables. The compiler will do that for you. So while you can manually call destructors, you almost never need to unless you're doing very special things involving placement new. You don't have to like manually run the destructors for your member variables or anything. The compiler takes care of all that for you.
Even if you have stuff on the heap.
Well, if you put it on the heap with new, then you want to call delete in your destructor. If you did new in your constructor, do delete in your constructor, in your destructor.
Or have a field that's a smart pointer.
Or preferably use a smart pointer instead. Very last slide, copy constructors. It's a special member function which is called when the compiler needs to make a copy of an instance, which is most usually when you pass an instance to a function by value. Right, so the compiler will run the copy constructor, and sometimes when you're returning by value as well, although there are various conditions where the optimizations will kick in and you won't actually get the copy constructor called, but in principle, it happens when you return by value as well. Usually, the copy constructor is provided for you, so if you don't write a copy constructor yourself, and various other conditions hold that are usually true, you will get a copy constructor provided for you by the compiler that will just copy construct each of your member variables in turn, which 99% of the time is what you want to happen. If you really want to, you can write a copy constructor yourself as a constructor that takes a single argument of type const reference to the same class. So this is a declaration of a copy constructor. I showed you what the definition of a constructor looked like on the previous slide. Whew, that was a whistle stop. And that's all I've got for you. Oh, that's too many. That was a bit racy towards the end. Not racy, I mean, I don't mean suggestive. I mean, I was racing. Yeah.
Maybe you have to press word on the default and delete.
Okay, so all the special member functions, so the default constructor, the copy constructor, copy assignment operator, move constructor, move assignment operator, you can use the equals default syntax to say to the compiler, please write this for me. And again, most of the time you'll get these anyway, so you don't have to do it, but in some circumstances you can end up, if you write your own move constructor, it won't write a copy constructor for you, so you can use the equals default syntax to put that back. And equals delete, you can actually delete any function you like. Mark any function. If you absolutely wanted to, for some reason, you could just take this member function here and write equals delete. It's not very useful, but you can do it. Most commonly, so now if anybody tried to call that member function, they just get a compile time error. Not very useful. Where it is useful is to specifically stop the compiler from generating a copy constructor or copy assignment operator for you when it otherwise would.
Sorry, I'm not stupid. Don't return on a copy constructor.
That's a constructor.
It's a constructor, so it doesn't have a return type.
I've linked you just paste into a slide, so to speak.
Okay.
So Tristan's going to stick the test in the slide. Obviously, the point of it is to gauge your knowledge. So if you don't know an answer to a question, just leave it. Don't guess it, because maybe you get it right and you just happen to get it right by chance. That doesn't really help us figure out where you're at at all. Take your time on it. Obviously, we've still got 45 minutes of the lesson left. So hopefully take as long as you want.
Oh, are we going to copy and paste this into the main Slack channel as well?
Oh yeah, I'll paste it to the side.
Yeah. Otherwise, you're going to spend most of your time trying to type this in exactly.
Well, it's on the Slack channel.
Is that first character? Is that an L or a capital I?
Fine.
Form slash.
Yeah, I'll pick a more cursive font. It should be a capital I. Oh. I would recommend going to our Slack.
Let me try changing the font to see if it gets any clearer.
Pick one that's serif.
Is that better? That is slightly better. So that's an O, not a 0.
Capital O. The thing at the start is a capital L.
I believe that's lowercase l, capital Y, lower x, lower f, lower x, capital A, jug. Yeah.
If you just go to our Slack, it's going to be a lot easier. Or you can go to the YouTube channel and go to the video.
Or we can do some tests as well.
So you talked that the deconstructor will work on member functions, but that's part of it. The deconstructor will delete or undo, reverse
What the constructor
what
did.
the constructor did, but that's within the
I'm
class.
sorry. Sorry, go on.
But for the free functions,
Yeah.
what's the resource management? Is there garbage collection or how do you?
There's no garbage collection in C++, but if you think about it, a constructor runs when you create a variable. When you destroy that variable, the destructor runs. Okay?
Quick note, it was taking your email address twice for some reason. I should have just fixed that. But it's changed, it means the link has changed.
Oh.
I'm gonna clear up a new one.
New one?
Yeah, I've got a new one.
Oh.
It doesn't matter which one you take, it's just that the second link doesn't ask for your email twice.
Do you want to shorten that, Tom?
We've already started, don't worry about it, there's no problem. It's just a bit annoying.
So the CPP lens,
Yes.
There you go.
Okay, we have a nice shortened link for you.
Funny thing is, that link it gave me was after I clicked shorten. Apparently,
That's 2OERJPZ, all capitals.
you're literally short. Not short enough for you,
Look at that.
that's much better.
I could use that as my password. Maybe you want to. Maybe I already did. We know which one. Which side. How is that?
No idea. This will expire.
Yeah, but that's
they probably did this week.
Oh, okay, that's definitely right. Are we sure this is the right? We're getting some CTV news. I don't think this is the right link, Tom.
It's not?
sorry.
What's wrong?
We're getting some Canadian news site.
Oh. Well,
That's
don't blame
what
me. I gave him the correct link.
Right.
That's what I was talking about.
Alright, I'll put the long link back up.
Yeah.
Right, this is the long link this
No,
time.
that's open properly.
Well, we've had two people.
The thing with Bitly is that
That was an O, by the way, in the last one, not a capital 0. Not a 0, it's a capital O. So maybe that was the difference.
Did you? Oh, you retyped it. Yeah, so it's 2
Ah.
OERJPZ, all capital. I mean, I
carrot under on you, not like O, not 0.
I can't type that.
2O, not 0. Is that right?
2 O, O for Oscar, P for Echo.
Keep it.
Yeah.
This is an O.
I'm glad that was only Canadian.
No, because that involves typing the letter O, which I can't do.
It's a frown upon to draw on.
Probably.
Oh, you know what I could do? I can use a post-it.
So in the second link, whoever didn't open yet, it's not 20, it's 2 and then capital O.
can't do it well. It's,
Can't really read that from the back end.
No, I'm on the internet, people can read that as well.
Yeah, to read it out again.
The address change.
Ollie just made a
So
minor
it
change to
doesn't
it.
matter. It doesn't
Doing
matter.
a test.
So I think you had to enter email twice, right?
Yeah.
Yeah, that's like this. It doesn't matter.
Is that what you wanted?
Yeah, that'll work. That'll work.
Going back so that there was litter collection, manual litter collection.
And your what?
Garbage collection.
Garbage.
So,
He said litter.
oh well. Oh, because C++ doesn't create much garbage, so he was trying to be funny.
Okay.
Yeah. There was a plan for a while to allow optional garbage collection. It never took off. It was sort of an idea that some people had. Wouldn't it be nice if you could optionally use garbage collection in C++ and then...
It's not getting rid of it, are they?
well, there have never been any implementations that I know of. It's
I mean, I think the bone, technically the bone GC would
kind of... doesn't work very well though.
basically the standard just said that you're allowed to make an implementation that doesn't require a delete for any that nobody actually bothered to do it. So if you do have anything that uses new, you're happy to do it.
Why haven't we covered like the overload constructors?
Because if you think like copy constructors and special constructors are effectively an overload. Overloading is a general concept that applies to free functions, constructors, member functions. So I'm not quite sure what you cover.
So like, okay, so I default constructors, overload constructors, assessor constructors.
Yeah, move constructors and copy constructors are a thing, but overloading is more of a sort of technique.
I'm not familiar with the terms accessor constructors and the other one. Not terms I've heard before.
The overload one they said was just the default constructor with
No, you can overloading is something you do on a function, a member function, a constructor. So I have one, like the default constructor, yeah? That's just a constructor with no arguments. You don't do any arguments, right? But then I have a constructor that takes an int, right? And then I have another constructor that takes a std string. That's what we call, that is overloading, because I now have two constructors that take one parameter each, but they take different types. That's all overloading is. You just have functions that take the same number of parameters, or potentially different numbers of parameters, but they're differing types. That's the concept of overloading. You can do that with functions, free functions, you can do it with member functions, you can also do it with constructors. There's nothing special about it. You can do it with operators. You can overload operators and give them overloads as well. So it's just a general concept rather than the thing. Line numbers do not start. Also, you don't really need to count. It's pretty unambiguous. There's only one thing there that matches what it says is the function. What could possibly be? Super easy.
Mm.
standard company. Doesn't matter. It's ambiguous. But you count to 0. You utilize
It's
it.
a markup, except it's not binary.
Well, I mean, it's definitely at least base 6, isn't it? It wouldn't matter if the last end is always 0. I don't, you haven't counted high enough to go
I
over.
thought of slime.
If it's something like 1 and 10, then maybe you could argue that that's fine. You do it. If anyone gets a perfect score, it's either Tristan, Justin, me, or you two.
You have great faith.
Clearly, the first answer is correct.
Sorry? I don't think you do. I'm not sure, actually. I didn't set it up.
I don't know. Maybe yeah. Okay. I've actually got somebody waiting for me. Yes. Okay. Get a counseling session. Yeah. Okay. Yeah. Yeah, that would be great. Okay. I'll wait for him for a couple of minutes. Is he coming back?
I think so. I think you just went to the bar.
Okay, cool. I'll wait.
That's a school teacher. We're talking.
Just one minute. That's right now.
Have you done it?
Yeah.
I put it on. I put them all on manual review because the last question there's no way for it to process it.
What is next week?
Sorry?
What is next week?
That's a good question. What did we decide on?
Sorry. Next week, we're
Can we
going
go on?
further with the more advanced material.
No. Object-oriented programming, or at least the introduction to it.
Yes.
Yes. So we're going to talk about classes and public and private protected, that we talked about before, and inheritance as well, probably.
Good to see.
Give me a sec.
Let's just look at your email.
The audio program.
Yeah, I got you. Maybe done a little lot.
What's that?
Actually, I think we're going to use rep email.
Oh.
Actually,
Really? It doesn't.
it's the one function. So that's it.
Yeah. Really? Wow. Oh, yeah. Oh. What is that? Oh, yeah.
miss one, that's a point off. If you miss two, that's 2 points.
Oh, yeah.
I filled up the list. What was I supposed to tell you? Yeah, well, all about two. So you can look through if you're interested in
Oh, really?
Bruce, then, yes, he's the man who's got all the.
What are we supposed to?
Just tick your name off, or if you're not on the list already, then pop your name on the list. You've got a pen? Yeah. I don't have a pen.
Yes.
So if you've been to any of these sessions before, you'll be on the list.
That's my first one. So.
Oh, I finished it too, but see if I can just read it.
Guess I'm not even
Just pop your name on the list. You've registered on our website as well.
Yeah.
Just because a lot of people register and then don't come along. So
Yeah, I would
this
say
one-
on specifically both sides, one or
Yeah.
plus.
Yeah, it's
Please.
yeah, sure.
Cheers,
Keeps them. So, do you want to just spend 5 minutes and then going through the answers, and then we can email everybody each individual scores once. So what we'll do is, because there are obviously quite a few of you, in about another 10 minutes or so, we'll go through the answers, and then Ollie's going to look at all your tests and mark them, and then you'll receive an email with your score, and then if you want to fight him, it'll be in the
Well,
pub
thanks for that.
afterwards.
That was really helpful.
You're going through the answers after we've submitted them.
After you've submitted them, yes, I'm afraid. We'll draw a halt to it in, say, 10 minutes.
I'm all done then, shall I just write it?
If you can.
I'll just take
So we're going to go through the answers. And then Ollie can go through individual tests if you.
Yeah. It's really difficult not being able to test.
Yeah.
Let's go and see where it's gone wrong. Exactly.
I saw this exactly. I thought it was great. In the main file, the declarative variables, in the header file, they have the member header class and member variables. And so above the class, they have that's like an overload constructor. And so we have the name of the constructor in parentheses, and then we have type to explain things, whatever was double. And so then on the main file, even though that constructor basically tied the variables from the main to the variables on the header. Yeah. Yeah, constructor. Oh, okay.
This one is a bit confusing to me.
Okay. But it's default constructor.
Default constructors.
So the default constructor, the default constructor generally has no arguments, right? Oh, okay. Yes.
Those two constructors. Two constructors. Same function name. Overloading is really difficult not to run.
Just to see what's right. To see what happens and how quick do the results come through.
Ollie has to mark them first, so he's diligently going through, but the results are coming quite thick and fast now, so
It hasn't burst out laughing at us.
Yes, I got to know.
You don't have to say the I of the
no.
okay.
So now, struct through, I've written three constructors for it. The first one takes no arguments, so it's a default constructor. Second one takes 2 arguments. And the third one takes 1 argument. That's const reference to the same type. So the third one here is a copy constructor.
Okay.
I'm going to get rid of this because it might help people out. But the point is that this has 3 constructors, so we describe them as being overloaded. Constructors are overloaded because they have the same name, but different argument types.
When you're naming the member variables, do you use the word new? Or you use the underscore?
That's just personal preference. You can name them whatever you like. My personal preference is that I put an underscore after the end of the name, just so that I'm looking in the body of the function. I know which is variables. It's just a stylistic thing. Like I said, other people very commonly use one. A lot of companies do this. I'll write M underscore in front of their member names.
I'm surprised they wouldn't have comments. It just says member variables. It's need to control that and find the whole number. Okay.
The sun's gone down. The sun has gone down. It is dark outside.
Is it?
Yeah. You see, the screen's turned a bit yellow.
Yes.
The nightlight thing has
Maybe
turned
you're still
on.
doing it.
Our friends, the yellow light shows in our eyes.
Yeah.
Some kind of background, which is very some toxins.
No, it's the blue light stops you sleeping, apparently.
Yeah, that as well, but as well, it gives you, it's like, destroys your eyesight. Because the blue light got the shortest wavelength.
Ready when you are, Ollie. Oh.
Still doing it. You can get into that as well.
I'm going to sign in. Yeah. Right. I'm not sure I follow.
You know, they want that object.
Well, if they're different concepts, if they're different ideas, if they represent different things, they should be different types, right? That's sort of a...
But once you created your app, your program, and then people come along after it's been set up.
Yeah. Yeah, it's like saying, okay, I've got this function that calculates the square root, and it's called square root, and someone says, okay, brilliant, can you make it take a logarithm instead? You're like, well, it's called square root, and everybody who's using it expects it to do the square root. if it's suddenly doing a completely different operation, that's very strange. Yeah, I'm trying to log in because this is silly.
30 seconds to submit. Five, four, three, two, 1, 0. Close. Right. Okay. Right. So let's go through them. Seems a reasonable number. You got this one right. Obviously, it's not a strongly caffeinated language.
It is
That's
when
not true.
It is when I do it.
No, it features strongly caffeinated developers, but the language itself not so much. So of course, it's a strongly typed language. I think everyone accepts that. So this one again, all structures have pass types have a structure, whether you write one or not. Yes, of course they do. It may be trivial, but it still has one. This one was a little bit of a trick. But I highlighted the trick with the star because you must explicitly return a number, and that's not true for main, and it does not require you to return anything. It's the only function in C++ that doesn't require that, so it's false. You do that. So obviously, if equals the equality operator, scope resolution operator would be colon. I'm supposed to be survey tonight. So of course, T and is a reference to T, and T star is a pointer to T. And then in this one, we've got A, which is an argument to the function, B, which is then a copy of A, and then we enter a scope, so that is valid, and we set C to B. So we can say that C lives longer, has a lower lifetime. A has a greater lifetime than B, B has a greater lifetime than C, and that's it. No, because it's the one question that is auto-scoring wrongly. Right. So next, declare a double called X. There's a bajillion ways to do this. I'm pretty sure I covered them all, but I'm manually scoring people, so I will. But for example, const auto D. X. Yeah. That is valid. I would manually score that as acceptable. It's ridiculous.
That is one of the many. Oh,
I'll change it. I'll give you negative one for being facetious. You could do const double X. You could do double const X. You could brace initialize. You could do const auto X and brace initialize. I think I put them all in. So either way, I'm manually scoring.
that was me just trying to be annoying.
Yeah. So select all the options that are true. Well, a function cannot be called if it's been defined, not true. Declared, however, absolutely. Function definition is header file. Ooh, that's bad. Will violate the one definition rule. In your source file, however, absolutely. And of course, ODR stands for the one definition rule. That's why you shouldn't put functions in a header. Well, you can't because it probably won't compile. If you use them from multiple sources, you get two definitions. Can't make it. Unless you declare them as inline, that's correct. So we've got a struct, as you can see. We've got the structor. Sorry that the comments bled over the side. It didn't look like that on my screen.
I think that's just because I blended.
Oh, is it?
No.
So sorry about that, folks. But you get the idea of the comment. So obviously, write the signature for the copy of the structure with no variable names. As much as possible. So it would be my class, and then const my class and, or my class const and, of course, and then a semicolon. I'll accept variations on that, so don't worry too much. Got it pretty much right. So select all of the types that I've made up or whatever. So std string, of course, is not a fundamental Right. Null doesn't exist. That's not a thing. Handle. Boolean also. It's bool, not boolean. Byte also.
That was a bit mean because there's a type called standard byte.
Yes, there's, but that's so well, 6-bit. And that should be all 5 of them. Just stuff.
Is it going to tell me that it's... No, but it's going to tell me it's closed. I may have to go through and do that all again. Just give me a second.
The problem that happens when doing it live.
It's open again.
C timestamps on the sheet.
It's quite difficult to do over your shoulder.
They're all optional. Just skip them. They're all optional.
Well,
No, they're not.
yeah, but I don't want to submit the test and end up getting...
Okay. Oh, this one is required.
More than one.
Just that's good enough. Sorry about this, folks. I didn't realise they were required.
Section 2. Yeah.
Section 2. Cool. Okay. Yeah. So consider this following code. Line 5 is obviously t and operator equals const t and other. It's the copy assignment operator. Oh, you really have to next. So what is true about this above code? Will it compile and run successfully? No, but I'll tell you why in a sec. Will it compile? Yeah, of course it will compile.
It's not obvious that it will compile.
I should have had that bottom one as the first option. The code will compile, but only if you use Microsoft Visual C++ compiler at midnight on full moon. Probably not. But it will compile, but it has undefined behaviour. The reason why is if you look, operator equals, is there a little laser thing? There is. Operator equals returns a t and. And what have we forgotten to do after C? There's no return statement. Should have returned started.
That's why there is string not included.
What?
Into the header.
Hash include string.
Oh, it's not.
And there's no hash include vector either, but you can pretend they're there.
Yeah,
That wasn't the...
not the point. Okay.
I said it doesn't work because it doesn't have string, so it doesn't know what the string is.
In fairness, if you thought that having no return should be a hard error rather than just a compiler warning, you're right, it should be, but for some odd reason it's not. So it will compile, but it just won't do the right thing.
Long C equals 0. That.
Yeah.
C is a long.
Yeah, so C is a member variable of type long, and we're having a default initializer. So if you don't mention C in the initializer list for your constructor, it just gets default initialized to 0. Yeah. So this is invoking this copy assignment operator. Well, don't forget these variables here. These names T and A and B refer to have type T. So they're not the same as this A and this B.
Yeah. Throw that in there, ladies and gentlemen.
Yeah.
So, what is the language keyword used for automatic type deduction, such as when declaring a variable? We saw it earlier. Auto. Given struct t int x, so not the one above, but this simple piece declared here. Right, an equality comparison operator as if it was a member function. So obviously you would do bool, operator equals const t and other. Yeah, const as well.
Oh, do we have to?
I won't fail you if you forgot.
Do we have to write the definition as well?
Yes, you'll see the definition. Perfect. I won't ding you for that.
Well, because it's correct, so you shouldn't ding before.
No, I mean, if you don't put it.
Oh, right.
I won't ding people if you forget it. Okay, so write a constructor for the struct T at the start of this section, which takes parameters for all three. So struct T again. So we know we have our
T had three
string-
member variables.
string vector and long. So
The vector of int.
yeah. So T, and then the parentheses, stood string. There's a few ways you can do this, and I didn't specifically say you must be const correct or anything. So there's a variety of ways that I've set. This is the most fitting way that you should do it. Stood vector int. Const. Y, and then the long Z, and then remember initializer list, so AX, BY, and CZ, and then ideally you would put the curly braces at the end there for the body that it's empty, but I won't do you for that. And then final question was, how do you think you did? This is just for us to get a bit of feedback. That's obviously not stored, but pretty sure you did pretty much perfectly. And that's it.
So in this case, if you're wondering why I didn't bother writing this as a const reference, it's because long is typically quite a small thing. So we don't, it's either 32 or 64 bits, 4 or 8 bytes. It's quite small. We're not worried about the expense of copying it. Whereas a vector could be megabytes in size. So we want to copy the vector as rarely as possible. So we have one copy to initialize it in here. We don't want to do 2 copies, one to create Y and a second copy to create B from Y. So that's why we take the vector as a reference here, and the same with the string. Whereas a long is a fixed size, it's very small. So we're not worried about, it doesn't cost anything to copy. So if we wanted to, we could do that as well, but it wouldn't really buy us anything. So typically for the small fundamental types, you take them by value rather than by const reference. Is that it?
That is it.
Any questions or anybody thinks, why is that answer that? Or does it all make sense having looked at it?
How does it compare with
This operator,
the, specifically because you have the represent
down
That's
here.
not the same B. That's a B reference.
No, I know what you're saying. So we're not using the return type. So what this is going to do is it's going to fill the return like stack variable or whatever it is. It's going to fill with junk. But since we're not really actually using the return value, we're not going to run into the problem. So it is undefined behavior, but it's probably not going to crash. However, it's still not very good, and this is something I think is wrong with C++, and I know it can't be fixed, but I wish it could be, that not explicitly returning in a function with a non-void return type should be a hard error. Anyway. Most of them will give you a warning, but not an error. So yes, any further questions about why things are what they are? No? Right, we better wrap up because we're well past time.
Cool. Oh, yeah, let's go and have a drink.
Thanks very much. So I invite everybody.
So yeah, you'll get individual, I assume 1 or 2 people have had them already,
Yeah,
emails with your responses in. And see you next week for object-oriented programming.
Yep. Yeah.